All right, so we're going to start with some solubility curves. This is the solubility curve extension, and we've already taken notes on solubility curves. You should have already had those notes. We've discussed it in class, kind of walked through a little bit with just me and you. Just with just me, where you're observing me going through it. This is your chance to put it down on paper or in your online notebook. So if you have not done so, go ahead and try to do all of this on your own first. Go ahead and pause the video, stop the video, go ahead and do all this on your own first. And if you need help, you just use this as a resource to understand what to do. So the first question, number one, says, it's not a question, but the first problem says, draw a circle on your graph to show a saturated solution. And I've already given you a circle. So you're going to draw a saturated solution of KCl, and KCl is this one right here. So anywhere on this line is saturated solution, and I'm going to copy and paste a couple of these. You could have put these anywhere here. You could have put them on any of these, and that would have been okay. Anywhere, that's the wrong line. Anywhere on the line that's labeled KCl would have worked. Now, if you had put one way down here, that would have been wrong. If you'd put it over here, even though it's close to the line, that's not on the line. It has to be on the line. All of these areas now, where I'm putting it, they are wrong. So that would be number one. It's showing saturated solution. Anywhere above the line would be supersaturated. Anywhere below the line would be unsaturated for KCl. If you get to the point where you're trying to move these and you're having trouble and it keeps like changing the shape or changing the size of it, what you're probably doing is seeing an arrow it's an arrow on both sides, and you're probably changing the size. What you need to do is move your mouse around until you see the plus sign with the arrows. It's going in all four directions. That's how you move it. Or you can just click on it and move the arrows. Either one's fine. But like use arrows on your keyboard. All right, how many grams of CaCl2 can be dissolved at 25 degrees Celsius? So when I see a temperature or grams, I'm going to go ahead and just try to draw a line. So I'm at 20. I said 25. So 25, which is right about halfway, is halfway between 20 and 30. So 25, that's the line. Now if you want to make it larger, or I mean not larger, but if you want to make it a little bit more obnoxious or clear that that's the line, then you can do that. So how many grams of CaCl2 can be dissolved at 25 degrees Celsius? Now this green line is 25 degrees Celsius, and we're looking for CaCl2, which is right here. It crosses almost exactly right there on 90, so the answer to this would be 90 grams. The question was in grams, so you should have been looking, your answer is going to be over here somewhere, and it's dissolved in 25 degrees at 25 degrees Celsius, and so it's 90 grams is your answer. Draw a square on your graph to show a supersaturated solution of CaCl2. So again, I'm going to look for CaCl2, which is the same one that we were just working with, and it says put this square where it's supersaturated. Now earlier we put it right on the line. Right on the line is saturation. Anywhere on that line is saturation. What we're talking about is supersaturation. So that is supersaturation because it is above saturation. This is saying 5 degrees Celsius, 95, 97, something like that, grams. That is supersaturated for CaCl2. Now, let's make a couple of these. You could also put one way down here. That too would be supersaturated because it is above the line. Do another one. Copying the wrong thing. Do another one. And we could put that right here. That also would be supersaturated. So you should have circles on the line because that's saturation of KCl. And for CaCl2, the line is going up. Excuse me, my battery's not. The line above the line is supersaturation. So we'll put that right here. At 0 degrees, at blank degrees Celsius rather, or so it's asking what degrees Celsius, that's going to be the answer. What is the degrees that it needs to be? At what degree Celsius is NaCl, which is this line that just barely moves up and down, what is that? 0 degrees Celsius, NaCl has dissolved 40 grams. 40 grams. So let's go ahead and do another line. We'll do a line at 40 grams. We may do this sometimes and see that it's not actually very helpful, that you didn't need to do it, but it does not really waste a whole lot of time, use up a whole lot of time. So the question says, at blank degree Celsius, NaCl has dissolved 40 grams at 100 in 100 grams of water. So that's just telling you 100 grams of water is just telling you that you're using this graph. You can see that over here on the side. So you could just delete that because you know which graph it's using. So at blank degrees, it's dissolving 40 grams. So where's 40? 40 grams NaCl has to go all the way over here. Delete this because I think it's crooked. 40 degrees is right there at 90. So this would be 90 degrees. 90 degrees would be the answer for that. All right, down here at the bottom, the dissolving rates of some solutes are more drastically affected by the temperature increase. So some solutes are drastically affected by the temperature increase. Which solute is most affected by increasing the temperature from 20 degrees, which is right here. I think my battery's on. From here all the way over to 50 degrees. So which one is more affected by that? Which one of the solutes is most affected? And if you look at sodium chloride, the one that's barely moving up, sodium chloride only changes like 2 or 3 grams. If you change the temperature from 20 degrees to 50 degrees, you can go from about 33, 34 degrees, of grams of sodium chloride up to about 35 or 36, something like that. You can only change it just a little bit. There's a very slight change. Now, if you were to look at other lines, this line, for example, goes from about 55, 56 up to about 85 or 86. So that's about 30. But if you look, the one that on this graph that does the most change is from 30 all the way up here to 90. That's 60 grams. I may have said degrees a second ago. That is 60 grams that you can add. If you were to change the temperature of water from 20 degrees up to 50 degrees, from 20 to 50, you could actually put a lot more of KNO3. So from, 30 up to 90, putting 60 more grams. But if you'll notice, KNO3 is not an option. So what we should have done first was look at the answer choices. So CaCl2 is right here, and it does go very, very steep, but it doesn't even, we don't have data for 50 degrees. So is that the answer? Is that a lot of change? We're not sure because there's no data point over here, so we'll mark that one out. NaCl, we just talked about how that one's it's super slight difference, so not NaCl. CeSO43 is right here. It's actually going down, but the change is from about 5 down to about 3. So again, minimal, kind of like salt, NaCl. And then KCl, where's that at? The KCl goes from about 32 up to about 42. So that's 10 degrees difference, and the others were either we're not sure or it was only 2 or 3. So KCl would be the answer in that case. Now to this one, we're going to answer just a couple of these. I'm not going to give the answer to all of these. Going through a couple should help you. So KNO3 at 70 degrees. So what it's saying is what mass of solute, how much solute will dissolve in 100 milliliters of water at the following temperatures. So KNO3 is this one right here. KNO3 at 70 degrees. So we can add another line if that helps you. At 70 degrees Celsius. At 70 degrees Celsius. I'll make that a little bit bigger so you can see it. At 70 degrees Celsius KNO3 crosses that line at about 130. At 130 grams of KNO3 at 70 degrees. Let's look at NH4Cl at 90 degrees. So we'll move this over to 90. It's a little bit off. We'll move it in a second. So at 90 degrees, where is NH4Cl? NH4Cl, it looks like it crosses right there at 70 grams. And Ki at 0. So if we remove this over here, all the way over here to 0, Ki is 130. There's 130 grams that you can put in there. So those are some of the answers up top. You should be able to do B and D. A solution contains 70 grams of NaNO3 at 30 degrees. Is it unsaturated, saturated, or supersaturated? So NaNO3, let's look at where NaNO3 is. NaNO3 is this line right here. And if it's at 30 degrees, I'm not going to draw a horizontal line, but if it was at 30 degrees, and where's it, 30 degrees and 70 grams, that would be right here where my mouse is. Now that is below NaNO3, so that's unsaturated. This would be oversaturated or supersaturated. This, anything on the line would be saturated. This one is unsaturated. If not saturated, how many grams of solute need to be added to become saturated? So we said it was at 70 and 30. 70 and 30, it would need 10, 20, 5. It would need 25 grams to get to solute, of solute to get to saturated. And the same question down here, solution contains 50 grams at 50 degrees. 50 grams at 50 degrees is right here. And it's talking about NH4Cl, which is what that is. It looks like it's right there on the line. That would be saturated. And how much does it need to become saturated? It needs 0 grams. It doesn't need anything. At 90 degrees Celsius, you dissolve 10 grams at 90 degrees Celsius. And if you had paper, again, you just write this on there. Write this, be scratching all over the paper. At 90 degrees Celsius, you dissolve 10 grams, which would be right here, of KCl, which is this one right here, this solute right here. So you dissolve, at 90 degrees, you dissolve 10 grams of KCl in the water. Is this solution saturated or unsaturated? It would definitely be unsaturated because KCl would have to be up here into 53, 54 grams to be saturated. So it's going to be unsaturated. So I hope that helps. I hope that makes sense to you. If you don't understand, I will look at some of the other videos that I've given you that you can work on. Trying to understand that. If you want to look up your own YouTube videos, do that. Look at just all the resources that I've given you. But hopefully that helps. And we'll do some more practice coming up soon.